World Authority on Chemical Nomenclature and Terminology, including the naming of new elements in the periodic table, on standardized methods for measurement and on atomic weights, and many other critically evaluated data.
Now we know that UPAC have rules to name the hydrocarbons, but why does it have them?
That's a good question, and here's the answer. The UPAC gave us those rules because if we want to name the hydrocarbons as we want, it wouldn't be possible to specify or to know which are which. So we have these defined rules to name the hydrocarbons because they are important. And they are important because without them, we just could confuse the name of the hydrocarbons and the chain that it has, the bonds that it has, the elements that it has. So it wouldn't be possible to name them correctly, and it wouldn't be possible for us to know which hydrocarbon are specifying there. So that's why is it important.
Oh, these rules are also applied with common hydrocarbons. Now I understand everything.
Types of hydrocarbons are unsaturated, saturated, and aromatic.
Hydrocarbons are the simpler organic compounds because they are made up of only carbon and hydrogen atoms. There are 4 types of hydrocarbons, as my friend says: alkenes, 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 and aromatics. Alkanes are single bonded. Alkenes are carbon-to-carbon double bonded. Alkenes are carbon-to-carbon triple bonded, and aromatics have sigma bonds. That means that they make like a circle. Their bond is circular.
An alkane is an organic compound that contains carbon and hydrogen only. It consists of single bonds between carbon atoms. When having an alkane in a chemical formula, the suffix you're gonna use is gonna be "ane" always. Okay, so here we have this chemical formula, and to get to this answer, you're gonna first need to identify the parent chain, meaning obviously the longest carbon chain, in this case this one that already circled. After that, you're gonna number all the carbons. 1, 2, 3, 4, 5, 6. You have 6 carbons on the parent chain, so you're gonna use the code or the suffix X because of the 6 carbons. After that, you're gonna identify all the substituents. The substituents are the appending groups from the parent chain. This one are the substance, like the ones coming out from the main chain. Those are called substance. Okay, after that, you're gonna, when you start writing it to get to the answer, you're gonna do it in alphabetical order. So you need to identify the group that has more number, all the carbons. 1, 2, 3, 4, 5, 6. You have 6 carbons on the parent chain, so you're gonna use the code or the suffix X because of the 6 carbons. After that, you're gonna identify all the substituents. The substituents are the appending groups from the parent chain. This one are the substance, like the ones coming out from the main chain. Those are called substance. Okay, after that, you're gonna, when you start writing it to get to the answer, you're gonna do it in alphabetical order. So you need to identify the group that has more substituents. In this case, carbon number 4 has 2 substances. Therefore, you're gonna start writing 4-ethyl because eth means 2 carbons. Ethyl/2 because then you need to return to your other substance because you have 1. 2-meth, that means 1. Methyl-hexane. You write hexane because hexane means your 6 carbons and you have the ane. because you're in alkanes. An alkene is a compound which contains hydrogen and carbon atoms as its major components. An alkene needs to have a minimum of one carbon-carbon double bond. This means that there's a double bond, so it needs to at least have one. When having an alkane, the prefix you're going to use is -ane. So, for example, in this chemical formula, to get to this answer, you're going to follow the IUPAC system, which tells you how to get finally the answer, obviously. So the first thing you need to do is identify the longest carbon chain, called the parent chain, in this case this one, which I already identified, and you're gonna number your carbons. You may be wondering why I started why I started numbering them the other way around instead of starting here. I did that because as we're in alkane and there's double bonds, you need to start numbering your carbons since, like, when you have the closest double bond. I don't know if you understand me, but as you can see, as I have a double bond here, then therefore, as we're in alkane, we need to start here, numbering 1, 2, 3, 4, 5, 1, which I already identified. And you're gonna number your carbons. You may be wondering why I started numbering them the other way around instead of starting here. I did that because as we're in alkane and there's double bonds, you need to start numbering your carbons since, like, when you have the closest double bond. I don't know if you understand me, but as you can see, as I have a double bond here, then therefore, as we're in alkane, we need to start here, numbering 1, 2, 3, 4, 5, 6. We have 6 carbons, meaning that we're gonna use the X prefix. Okay, after that, you identify the substance, which in here we don't have any carbons or any other element coming out of the parent chain, so that won't be necessary because there's none. After that, you're gonna identify the double bonds, in this case this one and this one, and to get to the answer, you're gonna write first your first double bond, 1, then you're gonna write a comma, 4, that's where you have your other double bond. You're gonna write X because of the 6 carbons you have, hexadiene, using the suffix of -ane because you have an alkane.
Okay, so let's get started with the alkynes. Alkynes are organic molecules made of the functional group carbon-to-carbon triple bonds and are written in the empirical formula of CnH2n-2. They are unsaturated hydrocarbons. Hydrocarbons are organic compounds that consist of only carbon and hydrogen. So the rules are: first, find the longest carbon chain that includes both carbons and triple bonds. Here will be our main chain. Then we're gonna number the longest chain starting at the end closest to the triple bond. So we're gonna go 1, 2, 3, or 1, 2. It is obvious we're gonna go from 1, 2, 3, 4, 5, and we're gonna go 5, 6, 5. Okay. After numbering the chain, we're gonna go and assign the lowest number to the alkyne. So we're gonna put the alkyne last. We're gonna go ahead and start by writing. First, we're gonna go to the substituents, which are these ones. So we're gonna write 4. Since there are 2, we're gonna write 4. We're gonna put a dash. D, because we have 2, 1 and 2. If it was 3, we will put 3, and if it was 4, we will put tetra. But since it is 2, we're gonna put D. And since it is just one carbon, we're gonna add methyl and a dash again. And now we're gonna go to the triple bond and we're gonna find it in the chain, and we're gonna go 1, 2. I'm gonna put a 2 here, and we're gonna see that they are 5. So we're gonna put pent ine. And that's it. Now we're gonna go ahead and go to aromatics. So now we're gonna go ahead and start with aromatic compounds. In 1825, Michael Faraday isolated a hydrocarbon called benzene, which consists of a ring of 6 carbons with 1 hydrogen atom attached to each carbon. Because many compounds containing benzene had fragrant odors, the family of benzene compounds became known as aromatic compounds. For naming them, it is pretty simple because when benzene has only one substituent, the ring is not numbered. First one, we didn't number the ring because there is only one chlorine, so we put 1 chlorobenzene. For the second one, we're gonna go ahead and number it. 1, 2, 3, 4, 5, 6. You don't have to do the whole thing, but it is just for explaining it. So we see we have 1 in the first one, so we put 1, and we see we have 1 in the second one, so we put 2. Since there are 2 substituents, we're going to put D. And now we have chlorine, so we're gonna put chloro, and we're gonna finish up with benzene. Pretty simple, right? So we're gonna go to the third example. We're gonna number it again. 1, 2, 3, 4. Okay. So we're gonna go first with the last one. So we're gonna go with 4 first. We're gonna put 4 dash bromo, because we have bromine here, and we're gonna go put a dash again, put a 3 because we have a chlorine in the third position, and we're gonna put a dash again, and chloro, and for the CH3, the name is don't mind this one. We have a series of IUPAC rules, which is that some are already named. For example, this one. So we're gonna use toluene. I don't know how to pronounce that, but we're gonna put it. And chloro. Toluene. And that's how you call the third. And for the fourth one, we're gonna go ahead and start numbering 1, 2, 3. Since we have the same ones, we're gonna start with the first one. 1 and comma, and since we have the same one, we're gonna put 3, as we did in the second example. So we're gonna put a dash. Since there are 2, we're gonna put D. Ethyl, because of the number of carbons. Benzene. And that's how you name it. It is pretty simple naming the aromatic compounds.